You are welcome to the Scholar Online class.
The Scholar School will establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
Good day, everyone. You are welcome to the Scholar Online class. My name is Uncle Sam, and I'm going to be taking you chemistry. Today, we'll be looking at atomic structure under chemistry, and we'll be talking about the concept of atomic structure. We'll be talking about subatomic particles of an atom, and lastly, we'll be looking at electronic configuration. Now, the concept of atomic structure. Atomic structure is is showing the arrangement. It shows the arrangement of how electron is distributed. Now, atomic structure, there's no way we'll talk about atomic structure and we'll not talk about atom. An atom is the smallest indivisible particle of an element which can take part in what? In a chemical reaction. An atom possesses the chemical properties of an element. Now, the subatomic particles of an atom, we have three subatomic particles. Particles. We have three subatomic particles. We have the proton, we have the neutron, and we have the electron. We have the proton, neutron, and what? The electron. These are the three subatomic particles of what? Of an atom. Now, the proton is positively charged. Positively charged. While the neutron is neutral. I'm talking about the charge now. The electron is negatively charged. Now, in electronic configuration of an element, we have what we call the nucleus of what? Of an atom. Now, in the electronic configuration, the proton and the neutron are found in the nucleus of an atom. For example, this is what we call a shell. We call it a shell. It is used to show the arrangement of electrons in electronic configuration. Now, here we have what we call the nucleus. And inside the nucleus, we have the proton and neutron. Inside the nucleus of an atom, we have what we call the proton and the neutron. And I said the proton is what? Positively charged. And the neutron is what? Neutral. So these two are found in the nucleus. They are found in the nucleus of what? Of an atom. The electrons are found outside. They orbit around the shell. They are found in the shell. This is where we have the electron. This is the electron. Electron. Now, in electronic configuration, electronic configuration is the arrangement of electrons in what? In shells. I said earlier that electrons are found what? Outside the nucleus. They are found on the shell. They orbit around the shell. And the proton and neutron, they are found what? In the nucleus. Now, what is this proton that we are talking about? Now, the proton is a number. The proton is a what? Is a number. The neutron and electron, they are what? Number. Now, the proton number is also the atomic number of an element. Now, in the periodic table, hydrogen is the number 1, helium number 2, lithium 3, down to sodium, calcium number 20. Now, the proton number is what? Is also the atomic number. And the atomic number is the number according to how they are arranged in the periodic table. We have hydrogen as the number 1. That is the atomic number. Hydrogen 1. And I said proton is what? Is also the atomic number. proton is equal to number of atom, or rather is equal to atomic number. So which means if the atomic number of hydrogen is 1, then the proton number is also what? 1. Now again, proton is equal to the atomic number and also equal to the what? Number of electron. Number of electron. Which means if the proton is one, the atomic number is 1, then the electron is also 1. For helium, on the periodic table, helium is number 2 on the periodic table, which means the atomic number of helium is what? 2. The proton number is what? 2, and the electron is what? 2. For lithium, same thing, 3. If the atomic number is 3, then the proton number is what? 3, and the electron number is what? 3. Now there is something we call mass number. Mass number. This mass number, in any periodic table, we have the atomic number. Let's say this is our hydrogen. We have the atomic number and we have the mass number. The atomic number is always repeated here and the mass number is repeated here. For example, lithium. The atomic number for lithium is 3. And the mass number is also what? Is 3. So, to get the number of neutron, lithium, the atomic number of lithium is what? 3, and the mass number is 5. So which means the proton number is also what? 3. Proton. Now I'm going to be representing this with the first letter. Now proton P is what? 3. The atomic number is represented with Z. The atomic number is represented with Z. And the atomic number is also what? 3. The electron number is also what? 3. Now to get the number of neutron, it is mass number minus the atomic number, the number of proton, atomic number. So we have our mass number to be what? 5, and atomic number to be what? 3. 5 minus 3, that is 2. Which means the number of neutron in lithium is what? 2. Is 2. That is the number of neutron in lithium. Now another example, let's take sodium. For example, let's move it higher. Sodium, Na. The atomic number of sodium is what? 11. And the mass number of sodium is what? 23. Now our atomic number is what? 11. Proton is what? 11. Remember I said earlier that our proton number is also the same thing as what? Atomic number. And our atomic number is gotten from the number in the arrangement of the what? Element in periodic table. Now our electron number is also what? 11. Now the neutron number is what? Mass number minus what? Minus atomic number. And what is the mass number? 23. 23 minus what? 11, which is equal to what? Equal to 12. So on and so forth. For calcium also. Calcium, the atomic number is what? 20. The mass number 40. Now the atomic number here is 20. Proton 20. Electron 20. Neutron, mass number minus atomic number, which is equal to what? 20. So moving forward, let's move to the electronic configuration of what? Of elements. The electronic configuration of elements. I said earlier that electronic configuration is the arrangement of what? Of electron in the shell. Now let's take sodium for example. The atomic number of sodium is what? 11. Now we want to arrange this electron in what? In shell. And in arrangement of electron, we have 4 shells. We have the K shell, L, M, and N. The K shell can take a maximum number of 2 electrons. Our L shell can take a maximum number of what? 8 electrons. Our M can take a maximum number of what? 8. And the N also 8. Now don't forget I said earlier that our atomic number is also the same thing as what? Proton number, and also the same thing as what? Electron number. So we are going to be moving this 11 electrons into what? Into their shell. Now for 11, I want to split this 11 into this shell K, L, M, N. Now we have 11. The first shell can accommodate 2 electrons. 2 electrons. Now 2 out of 11 we have what? We have 9, which means I still have 9. And 9 electrons, the second shell can what? Accommodate 8 electrons, which means I have 8. So 8 out of 9, we still have 1 electron left. The next shell can accommodate 8, but we have 1. So in writing electronic configuration of sodium, we have sodium to be 2, 8, 1. So to draw the shell, we are going to draw something like this. This is the nucleus. We showed the nucleus. And inside this nucleus, I said earlier that we have the proton and the what? And the neutron. Since we have this electron split into 3 shells, we are going to be drawing 3 shells. This is our first shell that can accommodate a maximum of 2 electrons. Our second shell, maximum of 8 electrons. And the third shell also 8 electrons. So we have 1, 2. For the second shell, 8 electrons. We have 1, 2, 3, 4, 5, 6, 7, 8. Now, the last electron, 1, you can fix it anywhere. You can bring it here or bring it here or anywhere. So this is the electronic configuration of what? Of sodium, 281. Another example, let's take chlorine, for example. The atomic number of chlorine is what? 17. So let's split it together. I said the first shell will take a maximum of what? 2 electrons. So we have 2. We have 15 left. We have 15 electrons left. The next shell will take how many electrons? 8. So we have 8. 8 plus 2, we have 10 out of 17. So we still have 7 electrons. The third shell can take a maximum of how many electrons? 8. So we have 7. 2, 8, 7. This is 17, and this is what? Chlorine. So we are going to draw the shell. Don't forget, show the nucleus. So you input your electron. The first electron 2, 1, 2. The second electron 8, 1, 2, 3, 4, 5, 6, 7, 8. The next electron 7, 1, 2, 3, 4, 5, 6, 7. So this is what? This is the electronic configuration of chlorine. You can also go on, choose any electron in the periodic table and try this out. Write out the electronic configuration of neon. We have neon. Write out the electronic configuration of scandium. We have scandium, we have titanium, vanadium, chromium. Write out the electronic configuration. Lastly, let us take sulfur. Sulfur. The atomic number of sulfur is what? 16. When you know your periodic table very well, you'll be very vast with all these elements and their atomic number. We have hydrogen, the first 30 elements for hydrogen to what? Scandium, titanium, vanadium, chromium to zinc. Now, sulfur is what? 16. Let's split sulfur 16 into this shell. I said the first shell can accommodate 2 electrons, right? So we have 2. The second shell can accommodate how many electrons? 8. So we have 8. 8 plus 2 we have 10, and so we still have 6 electrons left. 6. Let's draw the shell. Don't forget the nucleus, which carries the proton and the what? And the neutron. The second shell, be mindful when you are drawing this. The third shell, because we have 3 shells here. So we have 1, 2. Then the second shell, 1, 2, 3, 4, 5, 6, 7, 8. Now the third shell, 1, 2, 3, 4, 5, 6. Now don't be confused. I am representing my electron with this sign. You might open some textbook and find out that they are representing their electron with circle. You can represent your electron anyhow, but just show that your electron in the first shell is what? 2, second shell 8, and so on and so forth. So I've been able to talk about the concept of atomic structure, and I talked about the subatomic particles of an atom, and I said we have 3 subatomic particles, which is the proton, which is positive, the neutron, neutral, and the electron, which is negative. And I said the proton and the neutron can be found in the nucleus. They are found here. They are found in the nucleus of the what? Of the atom. And the electron, they are found outside the nucleus. Electron, they are found outside the neutron. This is our electron. Just as we have demonstrated that it is found outside the nucleus. And then we talk about the electronic configuration, which is the showing of arrangement of electron in the what? In the shell. So in our next class, we'll be talking about chemical bonding. We're talking about how various compounds, the kind of bond that exists between a compound. So we'll be talking more about the chemical bonding. So see you in our next class. And if you are just joining us for the first time, you are welcome to the Scholar Online class. Click on the notification button, subscribe to our channel, and then click on the notification button. Then you see a small bell. Make sure you click on that bell so that you can receive notification when we drop a new video. See you in the next class.